We have completed the first part of electromagnetic spectrums, where we are introduced to the different components of the EM spectrum. You know how are they arranged in order of their frequency and wavelength. Okay, and some of the general properties of the waves in the EM spectrum. So today this session will be on some of the uses and applications of EM waves. Okay, the different EM waves. Okay, and we are also going to talk about some dangers of electromagnetic waves. Okay, so you can see in this comic strips, okay, they say that, hey, people in some countries are removing telecommunication masts as EM waves are harmful. And then this girl replied, oh no, are EM waves really harmful? Aren't they everywhere around us? Okay, this is true. Okay, certain sections of the EM spectrums like radio waves are all around us. Radio waves, microwaves are all around us. Okay, but not all EM waves are harmful, just like what this guy is saying. I think a large part of the EM spectrum is safe when the intensity and the frequency, which is linked to the energy of the waves, is not too high. In fact, only gamma rays, X-rays, okay, are more of the harmful radiations. Okay, the rest are all quite safe. Okay, so we are going to learn in depth about some of the applications of each of these waves, okay, how they are used in our daily lives. Okay, the first one, the radio wave, we have learned in the previous chapter, it has the longest wavelength. So some of the characteristics is that it can travel over a very long distance. Okay, so what do we use them for? We use them mainly for radio communications. Okay, whenever you tune into your radio, like FM 95.5 and all, etc. Okay, they uses radio communication. And then when you switch on your televisions, okay, the television broadcasting also uses radio wave. Okay, in fact, all around us, there's a lot of radio wave going on. Okay, it's also used in radio astronomy and RFID tech. Okay, I will not go in depth into how each of these work. Okay, it can be found in your textbooks. Okay, and you can go on and read in depth how does each one of these works, how does each one of these uses radio wave. But the main property is radio wave can travel over a very, very long distance. So it can be used to transmit information over a very long distance. Okay, and then next we move on to microwave. Microwave slightly shorter than radio wave, but they are still very long. And the characteristics, one thing that puts microwave very different from radio wave is that microwave has slightly more energy. It has a little bit higher frequency than radio wave. So the best thing about microwave is because of this higher amount of energy, it can penetrate through the ozone layer, the atmosphere, into the outer space. Okay, so everything that is linked to satellite communication, okay, that whereby signals need to transfer out of the atmosphere, out of the ozone layer into the outer space, you need microwave. Although radio wave can travel a longer distance, but radio waves do not have enough energy because the frequency of radio wave is too low. It doesn't have enough energy to penetrate to the outer space. So anything that's linked to satellite, like your GPS, okay, your satellite TV, okay, all uses radio microwave. Okay, and then microwave is also used in your microwave oven for microwave cooking. Okay, and then in your mobile cell phones, okay, how data is transmitted when you're calling someone, okay, the wave sent out is by microwave. And then in radar, okay, which is detecting of foreign objects, okay, and then it can also be used in cancer treatment. Okay, next we'll move on to infrared. Okay, infrared is basically the wave emitted when an object is hot. Okay, you remember we had learned under radiation is a poor absorber of infrared radiation, is a good absorber of infrared radiation, etc. So characteristics of infrared, the hotter the object, the more infrared it will emit. Okay, so where are infrared being used? Okay, infrared is used in all remote controls. You know, on a remote control, there's a red dot that will light up whenever you press the remote control. Okay, so that's under infrared. Okay, it's also used in intruders alarm. Okay, and then used in thermal imaging when you go to the airport. Okay, especially during COVID periods, we use a lot of thermal imaging and a lot of infrared thermometers. Okay, because I don't need to have physical contact. It can just pass through air. It detects the amount of heat in our body. So if our body is very hot, it will change to another color. Okay, that's how thermal imaging and infrared thermometer works. Okay, it's also used in cookings and heaters to keep warm in cold countries. And then it's also used in data transfer in optical cables. Okay. Okay, next one, we have visible light. Visible light is the only part of the spectrum that can be seen by the human eyes. Okay, what do we use it for? We use it for photography, for photosynthesis, and in optical fibers. In optical fibers, we have total internal reflection in the light. Okay, and these optical fibers is used in medical. Okay, you can read about how optical fibers is used in medical and telecommunications. Okay, you can read in that yourself. Okay, and then next we have ultraviolet. Okay, ultraviolet is comes naturally from the sun. It helps our body to produce vitamin D. Okay, and some uses of ultraviolet is sunbathe for artificial tanning. So I don't need to go and stand under the sun. I can just go and lie down in a sunbed, whereby they use UV lamps, okay, to shine on your body, or babies with jaundice, okay, they will also lie in a sunbed, okay, that provides them with ultraviolet, okay, UV lights, okay, and then in the bank, okay, we also check for forgery of notes, okay, we use the UV light detector. So in UV light detector, you should be able to see this. Okay, and then it's also used in disinfection. You know, a lot of like UV sterilizer nowadays coming up. Okay, it can be used for disinfection. Okay, and then next we move on to X-ray. Just take note that X-ray is considered a dangerous ray already because X-ray is very penetrating. It can cause body harms. Okay, harms to our body tissue. So where do we use X-ray? Please don't give me X-ray. It's used in X-rays. Okay, it's used in actually medical imaging or X-ray imaging. Okay, or medical radiology. Okay, just add the word imaging. Okay, so this one is a picture of an X-ray taken by someone. Okay, and then it's used in CT scans in the airport. Okay, X-rays are also used to scan your luggage. Okay, so it's used for security scanning. And then in the industries, X-rays are actually used to detect cracks in any objects. So it's used for industrial defect detection. Okay, how does it work? So you can go and read more in depth in your textbooks. Okay, but X-ray, just take note that X-ray are harmful. So a person cannot be exposed to too much X-ray in a day. So every time when you are taking X-ray, the nurse or the doctor will leave the room while the X-ray is being passed through. Okay, so because X-ray is considered an ionizing radiation. Okay, and lastly, the most dangerous wave, okay, and has the shortest wavelength, travels the shortest, but is the most dangerous, has the highest frequency, highest energy, is your gamma rays. So for your gamma rays, very penetrating, a lot of harm to the body. What do we use to do? Okay, we usually use for detection of cancer and treatment, basically called radiotherapy. Okay, we can also use for disinfection because it can kill a lot of cells, can kill a lot of bacteria, viruses. Okay, so it's mainly used for sterilizing and detection of cancer and treatment. Okay, you can go and read more in depth in the textbook. Okay, you can scan this QR code to play a short game on EM Wave. So you have to, I think you have to match the cards with the correct users. Okay, then we go into some work examples. You can read this and pause. Okay, let's go through. They say that the velocity of the radio wave, you should know that all EM spectrum all move at 3 × 10⁸ meters per second. And then the radio station is broadcasting at a frequency of 1 times 10 to the power 6 hertz. What is the wavelength? So I give you the speed, I give you the frequency, I want to find the wavelength. You should know you are supposed to use the formula V equals to F lambda. Okay, so you start in the V, is 3 times 10 to the power 8 equals to the F, frequency 1 times 10 to the power 6 times lambda. You solve it. Okay, so it's 3 times 10 to the power 8 divided by 1 times 10 to the power 6. You should get 300 meters. That's the wavelength. Okay, next, you can pause. Okay, let's go through which of the following options is the member in order of increasing wavelength. Okay, you should know that radio wave has the longest wavelength, followed by microwaves. Okay, so if you were to use the mnemonics, you should be able to get B. X-ray is the shortest but have the highest energy. Microwave is the longest, okay, but have the least energy. Okay, next one. Name 3 regions with lower frequency than visible light. I hope you get it. Okay, lower frequency, that means lesser energy than visible light. You have radio wave, microwave, infrared. Okay, means very, very little penetrating power, very, very little energy. Okay, next one. Do gamma rays or radio wave have a higher speed when traveling in a vacuum? The answer is no, because be it gamma rays, radio wave, X-ray, microwave, all of them have the same speed, 3 times 10 to the power 8 in vacuum. Okay, okay, and let's move on to the last part. Last part is more about harmful effects of EM wave. Okay, so there are 2 main harmful effects. One is the heating effect and one is ionizing effect. Okay, so under heating effect is mainly under UV. Okay, ultraviolet is part of the EM spectrum. Okay, UV, when you have too much exposure to UV, what happens is the danger is it will cause our body cells to heat up and then you'll get sunburn. Okay, and it can cause premature skin aging and higher risk of skin cancer. Okay, then next, the last effects of radiation is ionizing radiation, which is mainly gamma rays and X-rays. Okay, so ionizing radiations are very high frequency EM waves. Okay, and what happens because of this high frequency, they have high amount of energy, they can penetrate our body very easily. Where does all this high frequency, where does all these gamma rays, X-rays come from? We can take a look at this chart. This mainly comes from outer space, cosmic rays, blah, 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 medical exposure, food and water, and all other things. Okay, so what are the harmful effects? Okay, you need to know because they are very high frequency, they have a lot of energy, they can actually knock out electrons from atoms and molecules in the body. And this will, when electrons are being removed from an atom, it becomes an ion. This ion will hinder chemical reactions in our body, okay, and it affects certain cell processes, maybe like your respiration, like your digestion, or any other thing. It affects certain cell processes in the body. And depending on the scale of disruptions, okay, how badly is this cell process being disrupted, it could result in cell death, mutations, leading to disease or organ failure. Okay, so basically it causes a lot of cancer because it causes the cell to change, the cell becomes from an atom, become an ion, and causes a lot of cell processes to change. So the cell will undergo mutations, so mainly cause cancer. Okay, and then so basically they are very dangerous because they can penetrate into our body. Yeah, that's it for the end of the session.